Okay, baton twirling. Jill is a drum major for the Dina High School Marching Band. For the finale of the half-day performance, Jill tosses her baton in the air so that it reaches a maximum height of 22 feet. This gives her 2 seconds to twirl around twice and catch it when it comes back down. Okay, reading through there, I see time again. Time is going to be usually always our independent quantity. And then after that, I see height of the baton tossed into the air. So that is going to be our dependent, and that is in terms of feet. Okay, so here's what we got left. We've already used B, we've used E, we've used H. What else have we used? And so we used D, we used G. And, okay, so that's what remains now. Okay, so think about it. We've tossed the baton up into the air really high. So it starts off by going up high, and then it comes down. So when I look at our three remaining possibilities, can't be C because C goes down to start off with. But then F and A, they go up, but the baton has to come down. So what that means is F is our graph we're going to use for this question. Okay, that is our independent, our x-axis. Our y-axis is the dependent. Oops, not dependent, because we actually have a name for that. It is height of the baton. And that's in terms of feet. Okay, now finish off this with the scale. So it says on this, this gives her 2 seconds to twirl around. So we're talking a very short time. Toss a baton into the air, it's not going to take minutes. It's going to come right back down. And where it comes right back down is where then she's going to catch it. So because of that, and we're dealing with something very small, we're going by 0.25 seconds. So 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, and then 2 is, I think, here. Now we tossed up into the air, and it reaches a maximum height of right here. That's when the baton reaches its maximum height, and then it's going to drop down, okay? So that maximum height, it said, was 22 feet. So looking at my y-axis, how can I get there to 22 feet? This is right here at 22. I'm going by threes. 3, 6, 9, 12, 15, 18, and there we go, 22. All right, next one, cold weather. The number of guests at a ski resort on any given day is related to the day's highest temperature. If the high temperature is negative 20 degrees Fahrenheit or below, no one comes to the resort. As the temperature increases, so does the number of guests. Once the temperature reaches 0 and increases through the single digits, the number of guests soars. If the temperature is 10 degrees Fahrenheit or higher, the ski resort is at full capacity with 400 guests. Okay, so on this one, I'm not seeing anything about time, as usually has been our case. What we have here is we have temperature, and then we've got guest, okay? So those are going to be using my independent and dependent. So as we read through that one, it's all about the temperature. Whatever the temperature is going to influence the guests. If it's too cold, guests don't come. And then once it gets to a certain temperature, there's going to be a max of how many people can come in. So what the independent quantity in this case is, it's not time anymore because we don't have time. It is temperature. That's going to influence everything. And that's in degrees Fahrenheit, okay? What's going to then influence the temperature, what's going to influence then is going to be the number of guests. The temperature influences how many guests there. If it's too cold, nobody wants to be there. But once you find that kind of sweet spot, people will be there, and eventually it's going to be getting to capacity. And once it gets to capacity, that's like a ceiling. We can't go past it. So in this instance, with what remains between your two graphs, A and C, it's going to be letter A, okay? So We label our independent, that's always our x-axis, temperature, which is in Fahrenheit. And then the number of guests, which is our, whatchamacallit, our y-axis, okay? Now, from there, we label out our scale. Okay, as we look at this picture here, okay, and based off of what happens, we're gonna make our scale go by fives, because what we're dealing with is right here, where the y-axis splits this x-axis down. Here's my positives, here's my negatives. Because of that, okay, this is one of the few times we're going to use the negatives scale, because it says at negative 20 degrees Fahrenheit below, nobody comes. So negative 20 is right here, negative 15, negative 10, negative 5, and then we're at 0. As the temperature starts to increase, so does the number of guests. And eventually, we get to this, again, max capacity, which is 400 guests. Can't come in there anymore. That's why you see that flat line. And in order to get up there, we're going to go by 50s, okay? All the way up to 400. And that's it. One more. Process elimination says you have graph C sitting on your table. Mr. Wright judges the annual Jelly Bean Challenge at the summer fair. Every year, he encourages the citizens in this town to guess the number of jelly beans in a jar. He records all the possible guesses and the number of jelly beans that each guess was off by. Okay, so the independent is going to be the possible number of jelly beans. We have no time here. And then the other part that's in here is the number of beans the guess was off by. Okay. Now, the x-axis on graph C is going to be the possible number of jelly beans. This one I'd say is a little tricky. I would give you guys this one. This one's pretty tricky. And this is the number of, again, beans the guess was off by. Okay. So we got a lot of jelly beans here, and we don't really have any good information. We're talking about beans in a jar, so I'm going to guess there's quite a bit of beans in a jar. So looking at what they have as a suggestion, we're going to use our scale to go by 100. Okay, and the number of guesses we're also going to use by a scale of 100. This one I would say is the challenge one of the day. Okay, all right, that does that. If you could do those other ones, I feel pretty good. That last one's a bit tricky one.